Hello, and we're back doing our grading. So this project was started in the last video. So if you haven't seen that yet, go ahead and take a look so you can see where we're at. We've defined variables, and now we're going to actually use variables and add them and do whatever we want to do. Let's go ahead and do that. And what are the operations we can do? So let's go ahead and put our comment line in here, and we're going to say that there are these type of operators, and most of these guys can be found on your numpad and are very familiar. So the first one, the slash here, is going to be our division. This is going to be our multiplication, addition, subtraction. We have the modulus. That's the one that one usually sticks out. Modulus just means remainder. So let's just do this a couple times. We're not going to use it in this program, but I do want you to understand it before we move on, because it's terribly useful in ways that you will find out as we move. So I could say, if I say 5 divided by 3 could leave us a decimal, but it could also leave us the answer of 1 2/3. Right? What happens, or in this case, the modulus of that is going to be 2, because that's what's on top of that fraction, that denominator is here. So it doesn't take into account how large the number is, because let's say I have now 27 fifths. 27 fifths is over 5. That is going to be equal to, let's say, 5 2/3. Oh, excuse me, not 5 2/3, 5 2/5, which gives us again a modulus of 2 again. Because again, all that you're worried about here with the modulus is what happens in the fraction. Now, some of you might be saying, well, is it always 2? No, it can be more than that. So if I have 7 divided by 4, 7 divided by 4 is going to be equal to 1 3/4. Now the modulus is equal to 3, because that is what's up here. Not a terribly simple, or not a difficult thing to understand, but in practice it's hard to think that way. Now, how would you do this in a program? Well, you'd have to say that x is equal to 7 modulus 4. So 7 divided by 4 would give us 1 3/4, or 1.75 to be more exact, if we're going to do decimal. But x7 modulus 4 is going to be equal to 3. Hopefully that makes sense. And if you think about it, then this relates directly to the data type, because a modulus, or a denominator or a numerator, is always going to be a whole number. So moduli, meaning modulus plural, tend to fit into the integer category. There's no reason to do these as decimals and doubles. Okay, but where does that leave us? Well, nowhere, because we wanted a test average, right? And how do we do a test average? Well, looking at our operators, we are going to do average, which we've already established, is equal to test 1 plus test 2 plus test 3, and then we're going to divide it by, and remember, we didn't do 3 here because we wanted to keep it constant, so we're going to say denominator semicolon. And as you do this, all of a sudden you'll see all these squiggly lines go away, because now we're using it. The only ones we don't use are string and character, which makes sense because at this point we haven't done that. But we can. In fact, let's do something with that today. So now we actually have a usable average. The one problem with this is that just like we have rules in math class, we're going to have rules here. If we do this equation in this order, what this is going to do is add test 1 to test 2 to test 3 divided by denominator. So the denominator is not going to divide into the sum of these three things. It's only going to divide into test 3, which we don't want, right? Because it would make test 3 look really small. But it would give us larger test 1s, test 2. So just like math class, we have these things called order of operations. Test 1 is, or a lot of times what we'll say here is that an operator is this plus sign, an operand, or what's being operated on, is called an operand. So we have to keep all these operands together and then divide by the denominator. And now we have, guess what? We have a usable piece. Now, can we add other things together? Yeah, well, you can add decimals, doubles, and ints. You can even add strings. So let's say we have string, and we're going to call it title. And we have we're going to do the declaration and the initialization all up here. Now, when you see the word string here, think double quotes. That's what's going to define it. Single quotes can define a character. So character A equals A. That works. If I do single title, meaning we'll call it find, we'll just say find for here, and I use a single quote and I'll say find, it's not going to like that, because it's going to, the single quotes makes it believe that, okay, this is going to be a character. If we want it to stand out as a string, we're going to use the double quotes. And now we're okay with that. It still has a squiggly line because it's never used. We're fine with that. And because I'm going to create another title called string title 2 equals, and I'm going to put a space first because I'm going to add these two together. Your average. Now, what happens when we do something like this? We do find. Oops. I'm going to say string, because just like we had to create a variable called average here to figure out these pieces, we have to create a string to do or a new variable called string to do the full title when we're adding title plus title 2. And I spelled title wrong, which is good. He caught it. And as you can see here, this is kosher, and we are adding this together. Now, does it add it like numbers? No. So in other words, it doesn't add find to your average. What it does is just puts your average after find and creates a larger string from it. So what we refer to this in computing as concatenation. The combining of two strings to make a larger string. And I think that helps us and makes it good. But so we are going to do something different in the next video, but what I want to do is make sure that you see this concatenation string in effect. And we're going to say, well, let's go to our form and let's create a label. And put it up here. And we will call this the label, well, we can leave it as label 1, but we're going to call this Label, instead of label 1, I'm going to call this label title. We give it a descriptive name, and now when we go into form 1CS, we're going to say label, and as you can see, it's right down there, so we can either use the arrows or try to tab into it, or I can just double click it and say label title equals full title. And here it comes up right away, so I can tab right into it and hit the semicolon. It does not like this yet because label title has a whole bunch of properties, as we just saw. So if I click on this one, clicking on this here, it has all these properties. So it says, well, what part of the label title do you want to associate with full title? Because it could be the size, it could be the font size, it could be the font color. But in this case, what we want to do is just say basically the text that we're going to fill that in with the full title. And let's go ahead and test this right now. I'm going to hit the start button, and the average is going to get computed here, but we haven't displayed it to the screen. So the only thing we're going to see here is the change of the full title. So if we hit compute, all of a sudden you can say find your average. That's actually a little underwhelming. So maybe we should stop that and actually capitalize this. There is actually a cheaper way to capitalize later on that I'll show you when we manipulate strings and characters. But here we go. When we hit computer and find your average, looks so much better now, right? Right. But we still have yet to display our average. It actually computes it because we click the button, so it does all this stuff. But we don't actually show it to the screen, and that's what we'll do in the next segment.